Hi, my name is Moolchandani, and I'm from Acrix. I'm the CISO and CTO at Acrix. I'm going to present today my talk on self-healing Gitops and how it's going to make a big difference in 2021. So just a little bit about myself. I'm co-founder and CISO and CTO at Acrix. I'm a big security enthusiast, and my favorite attack technique is waterhole attack. Just a little bit about Acrix as well. So we develop technologies that can self-heal cloud-native infrastructure by codifying security throughout the development life cycle. And we are located in Bay Area. We are a primary contributor to an open source project in this space called as TerraScan. And of course, we are also a HashiCorp partner. So what we're going to talk about today. Number one, so what is Gitops, right? How does it make a difference? And then we're going to quickly understand what is a pull request and a Gitops, because pull request is kind of a foundation behind whatever happens in Gitops world. And then we're going to see how the infrastructure as code is helping this world. We're going to look into what is Terraform, Helm, Customize at high level. And then we'll come and see what is securing Gitops and how we can achieve that using policy as code. And we're going to sum it up by showcasing that we predict that in 2021, we'll start seeing policy as code, which is going to be embedded with Gitops tools like Flux, using technologies such as OPA, which is Open Policy Agent. Ready to go? Exciting. All right, so what is Gitops? A little bit of brief history. Let's go through that quickly. We'll go through Gitops and we'll see what is pull Gitops as well. So just a bit of history. 2005, Git was created by Linus Torvalds. Git is a source code management system. And GitHub was launched in 2008, which is kind of when pull requests became really popular. Although the concept of pull request, existed before 2008, but with the launch of GitHub, it became like even more popular. And then in 2009, the first ever conference happened on DevOps, DevOps Days, which was held in Belgium, and that gave a huge push to this movement and practice of DevOps. 2014, Kubernetes got released. Infrastructure as code, first ever kind of open source big tool Terraform got released. And then in 2005, Helm Classic was released. So today, what we know as Helm was kind of Helm Classic in 2015, and it was launched then. Of course, it goes a long way. And in 2017, on August 7, we heard the word Gitops for the first time, which was the practice, which allowed the operations by pull request. So it's kind of the next level of DevOps, which allow you to do DevOps operations using pull request-based mechanism. So what exactly is Gitops? The Gitops basically is a code-based infrastructure and operational deployment practice that pulls the declarative infrastructure as code from Git repositories, and it uses DevOps practices for delivering high-velocity CI/CD for Kubernetes. Now, Gitops is also used for describing tools that use Git as the single source of truth for storing the infrastructure as code. And in order to deliver apps and deploy Kubernetes cluster, pull request-based mechanisms are used. For example, Argo, which is otherwise also called as Argo CD, Flux, Jenkins X, Scaffold, Kaneko, Tekton, and many others. These are all the category of tools. All these are open source projects I'm referring here, but these are all tools of Gitops. These are part of the Gitops toolchain. And if you can kind of take a look into this Venn diagram, it explains that how three different worlds are put together and the practice of Gitops is delivered. So you have Git, you have infrastructure as code, you have the DevOps practices. When you put all these things together and deliver a seamless experience for the practitioner, that's what is kind of Gitops. So let's take a look really quick into what is a pull request in the context of Gitops. We'll quickly try and take a look into this GitOps tool called as Flux. So you see, if you look into the diagram, what we see is we have a Kubernetes cluster, which has a couple of namespaces, and then we see Git repositories on the left-hand side in the diagram. There are two repositories. One is staging, one is prod. And Flux is installed as a Kubernetes operator in each of these namespaces. Each of the instance of Flux is connected to the repository. And then what happens is any changes about the infrastructure, declarative infrastructure as code, you mean to say, when they're pushed into the repositories, those changes are pulled by Flux, and then Flux goes ahead and provisions the namespace or the cluster accordingly. So that's how the pull request mechanism works. Just a kind of little bit more details on that because Flux runs as a GitOps operator for Kubernetes, you get full state synchronization with manifests that are defined in infrastructure as code and which live in Git repositories via pull request. You can have Helm charts or customized templates as your infrastructure as code in this particular case. And then you would realize that this is such a seamless experience for the practitioner that the infrastructure as code developer can keep pushing infrastructure as code into the repositories, and Flux can continuously pull that infrastructure as code and all the changes and continue to bring your state in a synchronized manner with the cluster and the infrastructure as code. So let's take a look into what is infrastructure as code at high level and also understand that how it is helping the whole GitOps practice world, including Terraform, Helm, and Customize. So we have Terraform, which is, as I explained previously in the history, was sort of one of the first big projects in this space. It is open source. It's a very popular open source infrastructure as code technology for cloud resource provisioning. And what that means is that it's great for provisioning compute, network, storage, and many other resource types for your cloud environments. It's fully declarative in nature, of course. So that means that you can codify your entire cloud provisioning system in infrastructure as code. It has its own language, of course, but it gives immense power to the DevOps teams to go ahead and now start codifying your provisioning architectures. Now, Helm is a CNCF project, which essentially is a Kubernetes package manager, but then it comes with its own templatization and style of infrastructure as code, which is again declarative in nature, and you can store you can store the Helm as Helm charts in your GitHub repositories as well. Helm helps you deploy the packages and manage the packages in a very seamless manner for your applications that you are intending to deploy on Kubernetes clusters. And likewise, Customize templates. So Customize is part of the Kubernetes tech stack, and it is used for deploying applications on Kubernetes cluster. Again, Customize comes with its own set of templates, very declarative in nature. You can fully define how your application should be packaged as well as how it has to be configured. All the different configurations that you would originally use, say in Kubernetes YAML file, right? You could do all of those things in Customize. So some of these technologies have become foundational for delivering GitOps on Kubernetes, and understanding these is kind of essential. So infrastructure as code is the heart and soul of GitOps practice, and these are some of the technologies which are helping a lot in driving the GitOps movement. Next, have you imagined that now you have GitOps practices which deliver and deploy the clusters and applications at an extremely high velocity? But what about assurance of security? Like, how does the GitOps tool give you assurance that whatever they're deploying is also secure in nature, or it's at least following the best practices and following the cyber hygiene of making sure that the policies that are defined by the security teams are actually enforced before they pick up the infrastructure as code and start deploying it on the cluster. Let's take a look how we can secure Gitops using a practice which is called as policy as code. So policy as code is a declarative method of defining policies for assessing your infrastructure as code. So imagine you've written infrastructure as code. Say, for example, you are trying to deploy a namespace in a cluster with a few applications. The applications are packaged, of course, in container images. Now you want to make sure that those container images are following certain security best practices. You define declaratively how to deploy the container images using any of the technologies, say Helm or Customize. But how do you ensure that they are also following the configuration best practices? For example, you don't want any container image to run with privilege escalation enabled, as an example. So that's where you take advantage of policy as code practice. Now, one of the very popular tool out there, which is again from CNCF, it's a CNCF project called as Open Policy Agent, is extremely helpful in providing a framework where you can apply policies to any type of infrastructure as code, essentially, and start assessing that for security and for security purposes. So imagine if you have policies written, OPA, Open Policy Agent, follows a language called as Rego. Rego is a popular language in that space. If you combine Gitops plus policy as code, you will be able to achieve secure Gitops. And in this conversation, in this talk today, I'm going to present my vision that in 2021, we'll start seeing this category of implementation where GitHubs is actually going to get combined with policy as code to deliver secure GitHubs. And not only that, it's going to go above and beyond just providing secure GitHubs. It's also going to be enabling the self-healing aspect of GitHubs. So imagine we're trying to deploy a cluster which has security problems from infrastructure as code assessment perspective, and the policies are failing, but your GitHubs pipeline is competent enough to make changes before the cluster is actually provisioned and self-heal the security problems. That's where the world is going, in my opinion. So automated security assessment of artifacts like Terraform, Helm and Customize, and the policy scans, which will be triggered on the pull request before the cluster sync, is essentially the technology of combining GitOps and policy as code to deliver secure GitOps. Now, cluster sync, when they can be halted based on policy violation, that gives you the capability of also achieving a use case which is called as born secure. So you don't let the clusters build if the policies are violated. So if the clusters are built, that means they are born secure. So these are some of the advantages. Let's take a look into what are some of the reference architectures that can be used for achieving policy as code with GitHubs. So in my reference architecture, I'm going to showcase how we can embed policy as code using Open Policy Agent and a GitOps project called as Flux. So in this diagram, you can see that Flux comes with two different type of Kubernetes controllers, one for Helm and the other one for Customize. And my imagination is that we are going to combine OPA, Open Policy Agent, with the controllers. And then at this time, when the Open Policy Agent is available within the Flux controllers as a additional capability, we can then perform our policy checks. So the policies are written in Rego, and our OPA Flux operator controller, which you see here in the middle, both for Helm as well as for Customize, is basically going to perform all the policy checking. And policies, again, are going to be written in Rego, which is a language for OPA. These are essentially security checks, right? So this way, you will be able to achieve all the use cases from the policy as code and GitHub's perspective. So imagine now when the container images or the deployments, when they're going to happen on the cluster, they're going to first go through your Flux controller, which is enabled for OPA checks. So now you are in a position to achieve policy as code with Flux. But then if you start making a little bit more modifications in this architecture, you will be able to achieve self-healing in a straightforward manner. So you can ensure that certain policies, if they're violating, you can break this process of the controllers not deploying the infrastructure as code as soon as the developer makes changes into the source code, or you can self-heal them. So Flux plus OPA plus Vego is one of the reference architectures that I'm predicting we're going to start seeing in 2021, which is going to deliver secure Gitops. So how to play with all of the things that I'm describing today, or what I'm talking about. So there are plenty of open source projects out there which can help you put together a architecture which I just described. I'm going to go through one of my personal choices, and I'm going to explain quickly that how this whole thing can be put together in a playground and you can start playing with it. So first, let me introduce you to an open source project, which I briefly mentioned previously, Terrascan. So Terrascan is an open source project that supports Kubernetes, Helm charts, and customized templates for policy as code assessment. It contains 500 plus policies out of the box. And then the second project that I have in my playground is Argo CD. Very similar to Flux. There are some fundamental differences, but more or less it operates similar to Flux. One of the major differences is that Flux can only operate on one single repository, whereas Argo can actually operate on multiple repositories. So there are other differences as well, but I've chosen Argo CD, which is again an open source project. Go ahead and install Argo CD, go ahead and install Terrascan, and then you can integrate Terrascan with Argo CD. I've provided full documentation of Terrascan and Argo CD integration. Very easy to do. All these are configurations. You can follow it on the links that I provided in the slide. And if you're interested, so to see whole of this into action and you want to see this demo working, then come and attend my upcoming talk today later on automated healing in Gitops and CD workflows, security without D-Days. I'm going to showcase this entire demo in a working presentation, and I'm going to also go through some of the intricacies of how we put together self-healing Gitops. Thank you so much.